Hey, I've got a great interview for you today with one of the founders of the dirty electricity space, really, Dave Stetzer, who, in conjunction with Dr. Martin Graham, developed the Graham-Stetzer Micro Surge Meter and the Graham-Stetzer Dirty Electricity Filter. We're going to talk about what is this weird thing called dirty electricity? Why should I care about it if it just has to do with what's going on in the wires in my home? We're going to talk about how to most successfully deploy this kind of solution within the home. We're going to contrast it with whole house dirty electricity filters and tell you a way that these plug-in filters can be used as a whole house filter in addition to being deployed around the home closest to the offending items. We're going to talk about some of his experiences, including with asthmatic children in a school setting and with two different types of diabetics. One is the juvenile diabetic, the type 1 diabetic, insulin dependence, and a decreased need for insulin. That's very interesting. Also something called a brittle diabetic, and what all of this has to do with dirty electricity. We're going to talk about the biggest dirty electricity offenders in the house, my personal fantasy of a next generation dirty electricity filter, and much more. Enjoy this interview with Dave Stetzer. Here we go. My guest today is Dave Stetzer. Dave is an IEEE senior member with over 50 years of experience in electronics. He's co-inventor of the Graham-Stetzer filter and micro surge meter. Dave, welcome to the EMF Remedy podcast.
Thanks for having me.
Yeah, this is going to be great. I'd really like to get into kind of an in-depth discussion about dirty electricity. And I guess the first question I would ask is, you are the co-inventor of the micro surge meter, which is an assessment tool to make an easy first discovery of what the levels of dirty electricity are in a home environment, and then also a filter that helps to address that. Why did you, what possessed you to develop those things?
Well, Martin Graham, who was a professor emeritus from UC Berkeley, best friend I ever had in the world, and he had over 40 patents to his name. Him and I were kind of teamed up together, and we both use an oscilloscope. We come from a technical background, so we can actually see what the electricity and what we're seeing there. And so we would see these waveforms, and we see all these high frequency transits and things like that. And so we thought, okay, it seems that they're affecting cows, and of course the farmers. It did affect daily milk production in cows. We could count them and we could say, okay, here's your milk production. If we had a lot of them, the milk production went down. It was that day. It wasn't like a lag of 2 weeks or something. So then if we didn't have so many, milk production would go up. But the farmers said, look, this doesn't just affect the cows, it affects people. When my wife comes into the barn, she passes out, heart palpitations. We're in a rural area, so by the time the ambulance gets her and she gets to the hospital, she's on a rubber-tired vehicle for an hour or more, and they get her to the hospital, they can't have anything wrong with her. So then they think, well, it must be psychosomatic. Well, we've been around a dairy barn, nobody would psychosomatic, or nobody would purposely fall down in the manure or something like that, okay? Yeah. But it's like, let's rule that out, let's see what's really there. And we could measure this stuff. So then an oscilloscope costs like $5,000. And so then we figure, okay, why don't we figure out a way of removing these frequencies from because where did they come from? They're on the ground. Well, they came from the power company. Well, the power company didn't generate them. So we looked at people's homes and office buildings, things like that. It's from modern day electronic devices, okay? So we thought, well, what if we go ahead and figure out a way of removing them? Then people should get better. And they did, okay? But then how do you know where to put these things? What are the levels? And not everybody's, well, first of all, hardly anybody's going to go out and buy an oscilloscope, can't afford it. So then I thought, well, let's figure a way of building an inexpensive, poor man's oscilloscope, okay? And we wanted to make it as simple as possible. So we came up with the micro surge meter, we call it. You plug it into the wall. There's not even an on and off switch. You just plug it in, you get a digital number. Now, the number is looking at energy. It's saying, okay, now there's a guy named Maxwell Planck who said energy is proportionate to frequency. So the higher the frequency, the more energy. Not only amplitude, where anybody else can only look at amplitude. Our meter, and we have the patent on it, we look at difference in voltage over the difference in time. So we're looking at how many times did that change voltage in a given time period. And so you get a digital number. So it's like I said, a poor man's oscilloscope. So you could have very low voltage, but if it's at a higher frequency, then you got a lot more energy. So it gives you a higher number. So that's how we kind of came up with the meter.
Got it. So with your, just a quick question here, when you're using your scope, are you looking just in the voltage domain, or are you looking in the frequency domain as well?
No, I'm looking at the shape of that waveform, and what changes the waveform, okay, is the frequency. Now, we invented two things, okay? One we call the Graham-Stetzer filter that removes this stuff from the line. But when we use an oscilloscope, we invented what we call a ubiquitous filter. It removes the 60 cycles from the meter. So it's sort of like, or from the line. So what happens, so we use a 2-channel scope when we look at the 60 cycle, and then we go through that little filter, and it takes the 60 cycle out. So it's like I use an analogy of going to Mexico and drinking water. Mm-hmm. Okay, we've invented a way of taking the water out of the glass, just the water. So what's left over is the bacteria, and that's what makes you sick. You can put it in a piece of bread and get sick. So if you go ahead and you look at this high frequency, after we take that out, and that's what that little Graham-Stetzer meter does too, that micro surge meter, it doesn't care. The front ends that of the meter, the electronics part, takes out the 60 cycle. So we're only measuring what's left over, the trash. How many parts per million, for example, of bacteria are on the wire or in the glass. So that's how that works.
Okay. And, we're going to talk about things like you just mentioned, people got better. So I just want to put a disclaimer in here. Neither one of us are doctors. We don't diagnose, we don't treat, we don't prescribe. And none of what we're talking about today is healthcare advice. If you have any questions in that realm, you should see your own healthcare provider. But tell me about some of the situations where you've seen people getting better, the environments where they get better. We were talking before. Oh, go ahead.
No, go. Well, fine. Well, one thing that comes to mind, we put them in a school district one day, well, 2 days actually. The school district hired it. They had what they called sick building syndrome, and the teachers union had a lawsuit against the school district because for sick building syndrome. And of course, they did the mold radiation. They did all kinds of things, put new carpet in, thought maybe there's a formaldehyde in the carpet, the stuff they always do. And of course, it's always mold. Nobody wants to look at electricity because it's sort of like a sacred cow. Okay?
Right. Couldn't possibly be that. Yeah.
Well, yeah, it's kind of like a sacred cow for utilities, things like that. So, okay. So one of the board members said, well, why don't we get, Stetzer there and take some measurements and stuff. And of course, the superintendent was very optimistic, or he wasn't really for it. But anyway, we went there and we did kind of an assessment and took some readings. And he said, okay, look, if that's the case, okay, this one room that we have up here should be the worst, right? Because people, we can only go a couple months there, and then we got to rotate the kids and teachers because they're getting sick. It's the sickest one. So those numbers should be the worst. Well, logically, it should be. And it was, okay? But then I use a scope. I seen the problem, so we fixed that. But nonetheless, okay, we put filters in. So we put them in I think November. In May, okay, they'd paid for themselves because none of the teachers, or most of the teachers, weren't calling in sick, and they paid for themselves by May by not having to pay substitute teachers. And then one mom was upset because there's 3 buildings. So we put them in 2 buildings one day and another building another day. Well, one of the moms was upset because little Johnny wasn't bringing his inhaler home to get, it refilled. And so she called the school nurse and said, hey, look, how come you're withholding my little Johnny's inhaler? She said, well, little Johnny hasn't come in to get a puff off of it.
Right. Yeah.
So then she's got to think, school nurse, right? She has to keep records of this. And then she said, come and think about it. Nobody else has either. Well, the school nurse was, the mom was pretty upset because obviously, school's trying to mess with little Johnny. So she wanted to have a meeting with the superintendent and the nurse. So she got her meeting. So the nurse thought, gee, I better kind of protect myself. I better do some research. And so she noticed that there's 37 kids that coming in and getting these puffs off the asthma, right, or this inhaler. So none of the kids in the 2 buildings came in after a certain date. The next day, none of the kids in the other building came in. So she was at a meeting in the teacher's lounge. She said, what happened to those dates? They said, that's the day we put the filters in. Okay, so now it's not a cure for asthma, okay? But when I was in Russia, I asked the guys about that. And so maybe they didn't have asthma anyway, because when you are exposed to these fields, your body will produce histamine, okay?
Mm-hmm. Right.
And so you have a reaction to these fields. And so, you can take an antihistamine. And of course, they gave me this. I said, yeah, but, how come this happened like this? Well, they said, look, there happened to be 4 of us there. And they said, okay, if somebody brings a cat in here, we're all allergic to cats. Somebody might break out in a rash. Somebody starts wheezing. Somebody's eyes start watering. All these symptoms. But we could take an antihistamine to get rid of it. But a better plan would be to get rid of the cat. And so that's kind of where, So that's one thing. Diabetes. There's people like Professor Magda Havas who thought this was it can't be true. So she did some research with MS. They've done research at schools. They've done research. She's done a lot of research with diabetics. And of course, the results were, wait a minute, this is really, can't turn out this way. Professor Sam Milham has done some research. It's all independent research, neurotransmitters in the urine, blood sugar, it's a number. So it's a real thing. And we're looking at very little low-level voltages and higher frequencies. And not high frequencies either. Because I went to Russia and we said, okay, which are the most biologically active frequencies? The World Health Organization, the Russian government, Japanese government says they're between 4 kilohertz and 100 kilohertz. Okay? So now I think about this, well, where are we exposed to 4 to 100 kilohertz? Well, a lot of the stuff that we have in our environment, for example, I'm talking to you, I have a MacBook Pro here. It's 12.5 kilohertz that it puts back on every wire in the house. I have a Dell over here to my right that's putting 50 kilohertz. I have some laptops, they put between 25 kilohertz and 50 kilohertz back on. Smart meters put 50 kilohertz back on the wires. Compact fluorescent lights, okay, the ones that look like a snake, they put between 50 kilohertz and 100 kilohertz back on the lights. LED lights, big thing now, right? Can't even buy incandescent. Incandescent puts nothing back. Safe, right? LEDs, 62.5 and 31.25 kilohertz back on the wires. So you can see they're the most biologically active frequencies, and we're surrounding our bodies with them on the wire.
Right. I think people could, and I think people who are trying to understand dirty electricity, I don't really love the term. I think conducted electromagnetic interference is maybe it's too technical term, but it kind of describes what's going on. And so you say, okay, we have this oscillation, if you will, going on the power line that doesn't have anything to do with the electricity you're paying for powering your refrigerator. These are itinerant frequencies, you could say, without a job really in your home. And they're traveling around the wiring, and people would say, so what? They're on the wires, can't hurt me. But the problem is anything that travels across an unshielded wire gets liberated into the local environment. So Would you agree with that description of another way to look at dirty electricity?
Yeah, actually, when we first found it, okay, Graham wrote a white paper at the University in California, okay, Berkeley, and he called it a ubiquitous pollutant and electrical pollution. Okay, so of course, we ubiquitous is a kind of a word that gets thrown around, but it means it's everywhere, and it really is. Okay, and so he called it electrical pollution, and so we kind of had this formal, university stamped term for it. Now I don't know where it morphed into dirty electricity. Um, but if we write any papers or something like that, we are usually referring to it as electrical pollution or a ubiquitous pollutant because we do have the definition for it. But yes, it is dirty electricity. But I agree with you on your and you got to remember somebody made it that way. Now, and it's really doesn't have to be because, for example, I'm talking about this MacBook Pro here, and we put 12.5 kilohertz back on the wire. Now, in the beginning, we didn't want to have a product to sell because we thought it took away from our credibility as experts. So we went to different manufacturers of different equipment and said, look, you could put a tuned filter on this computer or this, device, right? And it's going to be cheap because, you're putting it right in the switch mode power supply. They said, yeah, but it add $5 to the cost of the computer.
Right.
Well, in those days, laptop computers were about $3,000. So what's the difference? You're paying $29.95 or $3,000. You're all $3,000. So, so then finally we said, well, we'll make one ourselves, and the heck with you.
So let's talk about some of the worst offenders with regard to dirty electricity. The worst thing that I have in my home is a mini split. It's a form of air conditioning and heating where the compressor unit is outside. And by the way, on my unit, there's not one but two variable speed motors on the compressor unit outside, one on the compressor itself and the other on the fan that goes across the coils. And then on the inside, you have what's called an air handling unit. And that takes the room air in and then either heats it or cools it and redistributes it. And then on my unit, that's a variable speed drive as well. So that's kind of the king in my home. Other problems that I see with my clients, in addition to that, are like well pumps. People who live in a rural area, they have their own well. And sometimes they'll want to not have a large pressure tank. So you can do that with a variable speed drive on your well pump, but most people aren't aware that they're going to pay a big penalty in terms of dirty electricity. And I feel like the harm of the dirty electricity is proportional to the current draws. And you can comment on that in just a minute, but those are a couple of things. And we talked about LED lighting. I mean, we've had this safe incandescent lighting for many years. And now we're being asked to replace that with LED lights, which, it's like a little radio station built into the base of every one of these. And whatever frequency that station is operating at does get communicated back to all the wiring in the house. And of course, smart meters and whatnot. But yeah, if we could just talk about what are some of the main sources. You mentioned computers as well. And maybe your comment on the danger being in proportion to the current sometimes.
Well, first of all, a little prelude to that. The Russians did some research on rats, okay?
Let's mention why we talk about the Russians. I mean, they were, for the longest time, the world leaders, right, in terms of understanding the synthetic radiation environment.
Then they actually made weapons of this. But they did some research on rats, and they exposed them to a carrier wave. And a carrier wave is a repetitive wave, a high-frequency wave, but it's repetitive, same all the time, okay? If you take a crystal and you excite it, it puts out a certain frequency, but it's the same all the time. And then if we modulate it or change it, we can change it at an audio rate, for example, and we can get or FM radio station, for example. But okay, so they did this research on these rats and nothing seemed to happen. They go, well, gee, we know this stuff is bad. So, but it really didn't seem to bother them. So one guy said, well, why don't we go ahead and modulate the signal? In other words, let's pulse that wave. And when they did, within 3 minutes, all the rats were dead. They didn't even have time to make notes. Okay, so now we come along with variable speed frequency drives. First of all, in 1972, there was an oil embargo, so we had to get more energy efficient.
Let me just jump in here for 1 second. So when we talk about pulsing it, you can still have the carrier wave. You're just turning that carrier wave on and off. Sometimes it's on, sometimes it's off. So
yes, or varying the amplitude or changing it. Okay. So, but that's exactly what a variable speed frequency drive motor does. Okay. It's chopping that sine wave up, and the slower, and we still got some amplitude there and we're changing it. But if we still got the same voltage, but we're changing the frequency. So what happens is your mini split. See, like I said, going back to, we had to get more energy efficient. So now we want to use current in short pulses and get the same amount of work out of it. And so like your mini splits, variable speed, and even farmers, vacuum pumps, on their dairies, if you got a lot of cows in there, you need a lot of vacuum, hooked to a milker. But then as they start dropping off, you don't need quite so much vacuum. So then there's a sensor and it slows down the vacuum pump. Well, people put those in, then the milk production goes to heck. Why? You could drop 12 pounds a day in milk production with a VFD. Now, we know the manufacturers of this stuff. Okay, they know what frequencies they're putting back on. And so you can put some tuned filters in that particular drive. It isn't the motor that's causing it. It's the drive. So in your mini split, and you're absolutely right, you run into it all the time. At least once a week, we're helping out with a mini split, okay? We never used to have them. So, 20 years ago or even 10 years ago, we didn't see them. But now we're seeing it a lot, okay? So, and they are really bad, but, the problem's solvable. There's an engineering solution to an engineering problem. This is an engineering problem. But it shouldn't be you, and it shouldn't be me, and it certainly shouldn't be your clients or your listeners that have to fix this. This is the manufacturer's problem. Michael Dell, when he made that computer, he knows it puts 50 kilohertz back on the line. He knows how to get rid of it. He should get rid of it.
Should be illegal. Right.
Well, no, but it should be. Really.
Yeah, I'm not kidding. Yeah.
I'm the first to say that, and I'm selling a product that fixes it. And I'm be the first guy to be happy to say, hey, I'm going out of business here because they put tuned filters in these things now, and you don't need my product.
Yeah, so the best strategy, I think you and I can both agree, is to remove the source. I mean, just like an RF radiation, rather than shielding it, remove the source where you can. Now, if you've already invested in the mini split, I don't know if you're going to take it out and replace it or not. And, you certainly do have control of your lighting and that kind of thing. But it is those things that can't be replaced that we can look to, how do we make it better? And so the analog in the RF world where you're wanting to reduce exposure would be increasing distance or shielding. And you can't increase distance on dirty electricity because it's, the continuity and the wiring in the whole place. So then you're left with filtering, which I would say is an analog in the RF world to shielding. And what I mean by that is no form of shielding is perfect and no form of filtering is perfect, but we can make some pretty big dents in it. How best do people deploy your solution in a home? Because I think many times they can do this all by themselves. It's great if people want to have, and we were talking before we hit record here about in the earlier days, sometimes all you could do is address the dirty electricity and people would get better. And also when Wi-Fi first started coming out, sometimes all you had to do is tell them to turn off their router, and they get better from that. Now it's a much more complex kind of environment. So maybe you want to have somebody who's local and somebody who's qualified come in and help you with that assessment and remediation. But I think the deployment of your filters can be done by just about anyone. How do you best do it in a home?
Well, that's a good point. And we did try to do this because we said, okay, we want to make these so that the average person can do it themselves. That's why we had the cheap $120 meter or whatever it is, we made that so that you don't have to buy a $5,000 oscilloscope. And then you got to have, get these filters, and we give you instructions. And people call here, and we got qualified people that walk you through it. If you can't do it yourself, we try to make it that way so you don't have to hire somebody to do that. And we don't. I've yet to charge for, or anybody here for having people help out. And we can, we got Skype, we got Zoom, we got all these modern day things where we'll just set up a time. And we'll go ahead and we can, it's like us being there. And I just did it with some people in Nova Scotia here a couple of weeks ago where, the husband, he wasn't too sure and they wanted to get it done right. So we set up a time, and I spent a couple hours with them and they did it, in their house. And I said, okay, take this reading. Tell me what it said. But yes, what you can do is, first of all, there's big polluters in your house. One is your TV. You already know that. Your entertainment center. Computers are big problems, things like that. Okay, so go and you put a filter there first, because one thing about filtering, I mean, we'll sell you the filters till the cows come home, but we didn't do it to make money. We did it to help people. So we want to do it as effectively and efficiently as we can. So put it on, do your TV and your computers and your electronics first, because every time you plug one in somewhere, it lowers the numbers everywhere. Now, then you get a meter and you plug it into an outlet. You start somewhere, bedroom, hallway, whatever. There's two parts of the outlet, the top half and the bottom half. You plug one in, it doesn't matter. Plug the meter into top half, for example, you'll get a number. Then you plug the filter in and you want to see a significant reduction. And I define significant as 20%. So if it's reading 300, comes down to 100, obviously you did something there. Leave the filter. Now, 100 is still too high, but you don't plug a second filter. Go to the next outlet. If it's 300 or it comes down to 190 or to 295 or 290, that's not a significant drop. It just means you're not that close to the source. So go to the next outlet. Don't worry about it. You go around and eventually you'll see the numbers. Now, drop down. Now, any energy, if you made the human body into an electrical model, it would look like 3 resistors and 2 capacitors, called the UL 5-component model. You can look up in the internet if you want. A capacitor is a short to high frequency. So we as humans are a short to high frequency, but not until you get above 1.7 or 2 kilohertz, okay? Any energy above 2 kilohertz dissipates internal to the human body. So the filters are going to work at 2 kilohertz. But our meter, 50, not always, but we did some calibrations and things like that, okay, in Europe and in Kazakhstan and places. 50 on the meter is usually below 2 kilohertz. Now, when people did this research, like Hovis and Millman, these people, when they did the research, when the number was, it just, because you're going to know this when you plug the filter and you have no control over what the number comes down to. At the schools where the kids got better grades, no asthma, all this stuff again, what happens is the number happened to be around 35 or less or whatever, okay? But the same thing from an engineering standpoint would have happened if the number was below 50, okay? Because it's not going internally. So if the number is below 50, you need to check every outlet. You do not need a filter in every outlet or you did something wrong. So, but when you get the number below 50, the effects should be immediate, and they are immediate. In fact, if you're diabetic, within 20 minutes, you better take your blood sugar.
Yeah, right. Yeah, we were talking about that nursing home that you were present and Magda Havas was, and I just talked to Sheena Symington, and it was dramatic. I didn't realize it was so quick. You were telling me, what, less than a half hour?
20 minutes,
yeah.
20 minutes to an hour, you will crash. When Havas did research on the diabetic,
Yeah.
Okay. Nobody, and this is type 1, okay, that's where they use the insulin. Nobody had less than a 52% reduction in insulin usage.
It's almost like dirty electricity has an effect on energy production in the body or something, right? I
Well,
mean,
it affects the cells, that's for sure.
yeah,
So
yeah,
nobody had, between 52 to 92% reduction in insulin usage. So can you imagine? It doesn't make the drug companies happy.
right, right. And we were chatting a little bit before. One of my careers was on an ambulance, and I can't tell you how many times we ran on what's called a diabetic emergency, and typically that would be hypoglycemia, which can actually be life-threatening. And so we knew how to go in and use pharmaceuticals and get that person stabilized really quickly.
That's
The
when it
prop,
goes too low, right?
pardon me?
That's when it goes too low, right?
Yeah, that's when the blood sugar goes too low. So, and it's not like having too high blood pressure is not harmful. It's just not wasn't considered by us to be an acute event that needed to be save their life, treat them right there in the field. But we would get these individuals sometimes that are called brittle diabetic. You want to talk about brittle diabetics and observations with that?
Yeah. I, I shouldn't say like I like diabetes because but the reason we like diabetes was it was a number, okay? Like I said before, maybe the Dalai Lama can change his blood sugar psychosomatically, but you and I can't.
Right.
And so it's a number that we can plot against the number. Like we got this meter that gives you a number. So if you have a headache and we put filters in, your headache goes away. Only you had the headache. I can't prove that you had a headache or not. But so diabetics, we started doing little work with diabetics because it was a number. It's an easy number, easy to check, easy to do that. But the term, I never had heard the term brittle diabetic, but it's kind of like you're all over the board and nothing really makes sense. I mean, you can be too low and you give yourself just a little bit to bring it up and it takes it off the scale or something, whatever. So what we noticed is that whenever we cleaned up their electrical environment, they weren't this brittle diabetic anymore. They could get on a regular regimen, they could look at so many carbs and give themselves so much insulin and they're the same as anybody else, that way.
Yeah. And so earlier we were talking about, deploying the devices within the home. And so your advice was to just pick a place, and what you're looking for is at least a 20% reduction from the filter. And if you don't get the 20% reduction, it's not another filter that in that location is not necessary. Is that correct?
Right. If you don't get the 20% reduction, unplug the filter, go to another place.
Right.
Just because you're not that close to, just check the next outlet. You just work your way around the house. You don't have to be like a little detective, but every time you plug one in somewhere, it lowers the numbers everywhere. So eventually you're going to get to the point where, you're going to get numbers like 30 and maybe 35 because there's an A and a B phase coming into the house. So you're going to get two different numbers and you're going to plug it in. It's going to read 35 and plug it in. It reads 34. Okay. So, toward the end, you're going to see that there's really no change or very little. And so then you've done your job and you've done it right. If you have any questions, you certainly call. We're not going to send you a bill for it. I know some places when you call, they say, well, you're going to have to pay so much an hour or a minute or whatever it is. That isn't us. And we don't have machines here that answer the phone. We have real people. So, if it's ringing, we're busy. If nobody picks up. But, we have several lines coming in. We have all kinds of qualified people here that know exactly what they're doing, that'll walk you through it. And again, if they're really impaired or something, or really need help, even if you don't know how to do it and you're kind of older or something, and, if you get your grandson to come there and he doesn't know anything about it, that's fine. No problem. Let's make an arrangement to Skype or do something like that. That's still free. And we'll just, it's not an inconvenience for us. We did it so people could get better. And, if we don't like it, then we'll change occupations, I guess.
So let's compare and contrast the solution that you have with another solution that is available on the market, and that is a centralized whole house dirty electricity filter that's installed at the main electric panel. And there are a couple of manufacturers that build devices like that. So how would you compare and contrast that kind of a solution versus the solution that you guys are offering?
It's sort of like being an Amish versus us, okay?
Being a what?
Like an Amish,
Oh, okay.
The buggy versus ours. And I don't want to pick on these guys, but they're like Graham-Stetzer wannabes, okay? Graham and Stetzer found it. Graham and Stetzer have electrical backgrounds. That's all we've ever done. We're members of the IEEE, all that stuff, right? So we found it. We figured out a solution. But the first thing we did, okay, was we made a whole house filter, okay? And we did some research with the University of Wisconsin-Madison. And we took 20 people who had fibromyalgia, chronic fatigue. I think it was chronic fatigue. And so 10 people knew when it was on and night and day. We left them on for 2 weeks, off for 2 weeks, on for 2 weeks, off for 2 weeks. There was a switch inside. Nobody could know. So anyway, all right. So 10 people knew 100% better. Then they went back, reverted and stuff. 7 people kind of knew when it was on, when it wasn't. And 3 people said, well, they couldn't tell the difference, although the statistics showed they went to bed 2 hours later at night and got up an hour early in the morning. Graham and I look at things from an engineering standpoint. So if you come into a room and you flip the light switch on, we want it coming on 100% of the time, not 70% or anything like that. So the question is, why didn't we get 20 out of 20? So then when we put the part that we were involved with was taking the measurements. We didn't do anything about turning it on, turning it off, and the doctors took all that. That was sort of independent research. But we collected the waveforms, okay, in the people's homes. And we noticed that when we turned it on and we turned it off, the whole house filter, okay, on the ones that the people didn't get so good, the waveform didn't change that much, okay, the waveform that's inside the house. Now, the question is why? So we go back and we look at it and say, okay, but the people didn't get so good. These are sick people. So they got to occupy their time during the day. So they'd have big screen TVs and they would have, stereo equipment. They had a lot more electronic devices,
right?
Light dimmer switches, things like that, right? And the ones that got better didn't have all that. So then we thought, okay, what if we go ahead and make an individual filter that goes out and about the room, okay? Get it close to the source. If your TV's causing the problem, it doesn't get shorted out until it gets way over to the box or the panel, right? So if it's coming off the grid, that's great because it stops it before it gets in the house. But what about the stuff that's in the house? So then we thought we could get it better at the source. That's one of the things. The other thing, we looked at the frequencies. Remember, we were using oscilloscopes, so we can tell the frequencies. The whole house filters, there's a frequency, there's a bandwidth of filters, okay? And so it captures a certain amount. You get above 25 kilohertz, those whole house filters start dropping fast, okay? So the most biologically active frequencies are between 4 and 100. Well, if you got this Mac computer is 12.5, that's okay. So we went back and we made the individual filter, okay? Then we repeated the study and we had 100%. But we had to make placebos and dummies, and things like that to look like it. But yeah, so that's the whole house filter. Again, it's like driving down the road with an Amish buggy when you can be sitting in a nice GMC Denali driving down the road.
I tell you, I don't want a brand new car because of the RF implications. But right now, I would like. So, but I'm with you. I understand what you're saying. So, let's talk about maybe a possible way to use your filters other than what we've talked about in order to address appliances like a mini split or a variable speed pump that you just can't live without. Can your the idea of wiring in a couple of dedicated outlets right at the main electric panel, is that something, or would you do that?
That's a good idea.
To clean up what's coming from the grid.
Yeah, where I like, okay, usually you don't have to, okay? But if you can't get those numbers down to where we want them, then we need to, because it's either coming from in the house or from the grid. And a lot of times from the grid, and you can't help it, because if you're living kind of by a factory or something, or here's the worst thing, if you don't have it, but because at least if you have it, it's under your control. But if your neighbor has solar,
right,
then you got 20 kilohertz. And remember, 25 kilohertz is non-Hodgkin's lymphoma. So 20 kilohertz being on the line, right? So you got to get rid of that. And you can't go to the source because the inverter's putting it on. So then you got to put you don't want it coming into your house at all. So then I usually have an electrician come. Well, I don't, but like the people, if
for the client, people who are not electricians,
client, okay? And it's about $100 worth of material. You need 4 receptacles, right? Duplex receptacles, and you need this cover in the boxes, 2 4-inch boxes. And we put like a 4-plex, what we call a 4-plex, because there's actually 4 places to plug in, but 2 outlets fed from A phase and 2 outlets fed from B phase. Okay, so that's say $100 if you don't have it. The electrician has to put it in, and then you're out, probably what, $40 or something for, so 80. So you're out less than $200, to put this on. But it's still a long ways from a whole house filter. And now you have a whole house filter, and you have a better one because you were looking at, you're working at 1.7 kilohertz and you're stretching way out into like a meg, that's going to clean up that line.
Can you connect between the 2 phases?
Go face to face? You don't have to.
Okay.
No, you don't have to. You can, okay, but then we got to change the filter, like like a 2, because you'd have 240 volts there. Then
right,
we got to change.
Okay.
You'd have 240. In Europe, we have filters for Europe, and we do have it for 240. But then UL, they're UL approved, but UL and of course Canadian Standards Association for but CE has to be for Europe. And the rules are that when you unplug that filter, because it is a capacitor, okay, capacitors can hold a charge. So when you unplug it, you have to within 1 second be discharged. Okay, well at 120 volts, we got to have a certain time value there. So we have to use 1 size resistor. And of course, for Europe, then we got to use double that because you got double the voltage. Okay. So you don't want to hook it at 230 or you'll hear it popping and sizzling, and that's a resistor burning up inside.
Yeah. Once you let the blue smoke out of those things, they don't work so well, right?
Oh, yeah, right.
So, and on that note, sometimes when you plug in this kind of device, it'll make a sound, and that's not something to be alarmed about.
Capacitor. It's a capacitor. The basic component is a capacitor. Okay, a capacitor charges at peak voltages. Mm-hmm. Okay, so when you plug it into the wall, you have 335 volts there. And now for the people saying, you're crazy, it's 120. No, it's not. It's really 335. Voltage is measured peak to peak. Okay, and that's what people feel, and that's what's there. Now the RMS is 120, root mean squared value. In other words, if you had a DC heater, for example, how much heat would that come on? How much voltage would you need? If you had a 120 volt battery, okay, you're going to get a certain amount of BTU heat off of it. How much AC do we need to produce the same amount of heat? Well, the answer is 335. So we actually have 335 volts there, but now we just kind of say everybody uses RMS as a term, but it's 120 volts RMS. But the capacitor is charging at 335 volts. So when you do put it in there, you got a 335 volt arc if it's on the top maximum positive or maximum negative. If it's going across 0, you don't get a pop. But it's just a one-time, pop, and that's the end of it.
Right, and just that people would know it's not something to. Don't be alarmed. It's not something to be concerned about. It's fairly normal when you plug these things in. You might get a snap or a crack or whatever, right? Yeah.
Yep. Exactly. Yeah.
Okay.
But I've been asked that question probably 1,000 times.
Oh, I'll bet. Yeah. Yeah. So, and your product is or is not UL listed?
Oh yeah, it's UL approved. Yep. UL CSA, Canadian Standards. Yeah, absolutely.
Okay. So I want to talk about my ideal product for the future. Are you guys thinking of what I would really love to have is something the size of a circuit breaker that would fit in your main electric panel. And I know this is probably not a realistic dream, where I could tune both inductance and capacitance at the same time. Such a thing, I'm sure, doesn't exist, but there is a magnetic field component of dirty electricity, and I want to get your thoughts on this because the wavelength is so long, and because you don't have coherence in electromagnetic fields until you're in the far field. We need to examine both the electric and the magnetic fields separately. And so if you have troublesome voltage transients or residue from switch mode power supplies of whatever type, or something that comes in dirty on the electric grid, there's going to be a current related magnetic field aspect of that as well. So can you talk about that a little bit? And is that an opportunity for something in the future? Is it something we don't need to worry about? Is it something that can or can't be addressed in a capacitance device? I'd just like to have a little discussion about that.
Well, again, I'm not a doctor. I don't know. I can't offer medical advice. But what we've found, okay, and what I've seen, and I've been doing this for a long time, and I actually got to the point where I quit doing it because I was pretty much right all the time. I could look at that waveform and I could tell you what you were suffering from, okay? Like a doctor reads the EKG, I guess I was looking at that and I say, well, look, you got this. But a few times I said you got cancer and people got mad at me because they didn't. But then when they went to the doctor, they had cancer. So then it's like, oh, no, so I didn't like doing it. And I predict, but I could look at the amplitude and the waveform. So what I've found and noticed, and I'm not sure, we do all this research on the 60 hertz, okay? But after being in Russia and stuff like that, they didn't seem to bother people too bad, the 60 part, or they have 50. I'm not saying it doesn't hurt you, because it can, and it does, and there's plenty of research that says it does. But what we noticed that if it's dirty, it does bother you. So the filters take out the dirty, okay, for sure, okay? And I was in Russia, and there were some scientists that were arguing. They said, okay, they were arguing with each other. And they said, we did good research. And the other guy said, no, you didn't, because our research shows that this doesn't hurt you. And they're talking about the fundamental frequency, like 50 hertz, okay? And so I was there as a guest, and I said, well, guys, did you save the waveforms? Yes. So what they found is that if it was dirty, it caused cancer. And the ones that said it didn't cause cancer, that the results were inconclusive, it wasn't dirty. So does 50 hertz hurt you or not? And both of them were saying, one says it didn't, one says it does. But now they both agreed, both sides. It was the high frequency that causes it. If you're living in New York and you say, well, I get sick from the water, and you're drinking water in Veracruz, Mexico, and you're getting sick, right? So the guy in New York says, no, water does not make you sick. And the guy in Veracruz says it does too. Let's look at the water. That's what Graham and I did. We looked at the water. We looked at the waveform. And when the water, we figured out a way of draining the glass of water, and what was left over was the bacteria. In Veracruz, so both of them are right, okay? The water didn't make the guy sick in New York, and it really wasn't the water that made him sick in Veracruz. It was the bacteria. So it's the high frequencies on there. So, but I don't know. The jury's kind of, out on that. All I can go by is experience, and I know that when we cleaned it up, the symptoms went away. We know we went to Sam Milham, who was a professor emeritus from Washington State, former head of the health department out there, wrote Dirty Electricity, wrote several books and papers on it. He collected urine from people for 12 weeks at the Olympia, Washington Library. nobody had less than 300 neurotransmitters in their urine. Okay, so neurotransmitters are like the electrical grid of your immune system. So if you get a cancer cell in your ovary, it sends a signal up to your brain and says, hey, something here doesn't belong. And the brain goes back down. Okay, I'll send something down to kill it. Okay, so you don't want to have any neurotransmitters coming out of your urine because they're leaving your body, going through your kidneys and right. So I flew out there just to make sure that they did it right, so nobody could argue about, we put filters in and they didn't do anything. If they only put 2 in, they could say they put filters in. Okay, so the number have to be around 30 or something like that, 35. I don't know. I can't remember the paper, but anyway, within 8 hours, because there's 2 shifts, within 8 hours, they collected the urine again for 12 weeks. Nobody had more than 3 neurotransmitters in their urine. So the effects are pretty much the same. Now, we didn't change anything, just the high frequency transients. That's all we removed, okay? I know Wi-Fi was still there. I find people with Wi-Fi, you can't sleep, you get headaches, all kinds of stuff. So I'm not saying Wi-Fi is good for you, but the most biologically active frequencies are what's on those buildings' wires. And that's the ones you'll get the biggest bang for your buck by removing them, okay? Now, you still got to tweak it. There's no arguing about it. I go to a hotel, they got Wi-Fi. I can plug filters in my room, but I can't turn off their Wi-Fi. And I can't sleep. I'll toss and turn most of the night. And if I go to somebody's house, my son has his Wi-Fi on, I got to go down to the basement and turn it off, or I can't sleep.
Mm-hmm.
So, and I wouldn't say I'm sensitive. And the thing with it is about sensitive, people say, well, I'm sensitive. And somebody isn't sensitive. That's not true. We all react. We're all humans, okay? All the cows reacted to these transients, some more than others, but nonetheless, it's just that the people say, well, they're sensitive or they notice this. They've made the connection. Like you made the connection of what was causing your problems, But unless you made the connection, you can go to the doctor and say, I got a headache. He'll give you a pill for your headache. But once you make the connection, and nobody's Superman, everybody's affected by it. It's just you're affected differently, or you don't notice it as much, or you become more sensitive. And if you had one radiation, okay, the resistance of your internal organs goes down. That's right out of a book by Dr. Karl Mara. He did a lot of research on this in Prague. He was the head of the research center there. And so what happened is the lower your resistance, the more current is allowed to go through you then. The more current that goes through you, the lower your resistance. So it's a spiral going downhill. And you're just going to get worse and worse and worse. So that if we can stop that, your body will recover.
All right. Well, that sounds like a good place to end our discussion. And I just want to thank you for the work that you're doing in, bringing this product to market and your tireless activities in helping people day to day to deploy these. And I just want to thank you for spending some time with us today and answering all these questions. And how can people get in touch with you?
Well, we got StetzerElectric.com. There's a website. And if you want just me, I mean, you can send, I think, help or something. I'm not the guy that takes care of that. But you can send it Dave@StetzerElectric.com, and I'll answer your email. Or you can call me, and I'll answer your phone call, or they'll get it to me. And I might not be able to take it at the particular time, but I will return your call. There's nobody that can say I didn't return their call or something like that, and I'll talk to you as long as you need. And like I said, you're not bothering us. If we start to think it's a bother, then we'll get a different occupation. I mean, that's our calling in life or something here. But yeah, we're here to help you. And Dave@StetzerElectric.com. Easy to remember.
Yeah, what a concept. Returning people's calls and helping
them
with...
and no machines, really.
Yeah.
I hate those things.
Yeah.
So I don't want anybody else to have to go through that stuff. You're going to get a real person, no AI here.
Fantastic. Dave, thank you so much for your time today. I appreciate it.
Thanks for having me. Sure.